Today our topic is specific gravity. So specific gravities. In specific gravities, mainly two types of specific gravities are available for soils. So for this specific gravity of soil solids, or maybe it called as specific gravity of soil, or true specific gravity, or absolute specific gravity. So the definition is it is the ratio of the unit weight of soils to the unit weight of soil solids to the unit weight of water. So generally the ratio, the range between the range of specific gravity is 2.65 to 2.8. So other definition for this one is the ratio of the volume weight of a given volume of soil solids at a given temperature to the weight of an equal volume of water. Okay, so next one, apparent or bulk or mass specific gravity. It is defined as the ratio of bulk unit weight of soil to the unit weight of water. It is the ratio of bulk unit weight of soil to the unit weight of water. Where in this place we can remove we can replace this one with bulk weight, or you can may replace with gamma d, or you can may replace with gamma sat according to the problem situation. Okay, so these mainly these two types of specific gravities are available in soil. So it is the apparent or bulk or mass specific gravity. So there are different types of names for this type of specific gravity, and also for this type of different agencies, different textbooks authors using different types of names. So all of type names are you should must be remember. Okay, so next one. So therefore here also specific gravity there is no units, because it is the ratio of bulk unit weight by bulk unit weight. So therefore gamma by gamma, so there is no units for specific gravities also. Okay, next one, interrelationships between the fundamental definitions. These are most of these we are already covered in the last lecture. So for example, for that I will give one more example for this. So that is the most important parameter, or the interrelationship between the soil particles is this equation. This equation, how can we can get by got by step following these steps. So in these steps, first the bulk unit weight is the bulk unit weight is we can get by, it is a ratio of weight by volume. Okay, it is the ratio of weight by volume. However, the weight may be constitutes of weight of water plus weight of solids. Okay, the W means it is the total weight of solid. In total weight of solid, it may be weight of solids plus weight of water. Same volume. The volume of solids, volume of solids plus volume of voids. So by common in the numerator Ws, and denominator Vs. So while common from the Ws, we can get this like Vs like this way. So but you know that weight of water by weight of solids, what we know, it is the water content. So water content means it is the ratio of the weight of water by weight of solids. So in this place we can replace by water content. And also the volume of fluids by volume of solids, what we know, it is the void ratio. So volume of fluids by volume of solids is void ratio. Next one, ws by vs. In this parameter we have to follow these steps. Gamma s, it is the unit weight of soil solids, it is the ratio of weight of solids by volume of solids. Also for this equation we have also another formula also for the in relation to the previously explained the specific gravity. Specific gravity is the unit weight of soil solids by unit weight of water. So unit weight of water is transfer this to here. So automatically we get unit weight of solids is equal to g into unit weight of water. So here also gamma s, here also gamma s. So um, equating both this equation and place this equation in this equation. So by ws by vs, ws by vs, we know that g into gamma w. So directly we can replace this ws by vs is equal to g into gamma w. Okay, so g into gamma w. So for this same automatically while final equation is the coming into front. So g into gamma w, so therefore 1 plus w by 1 plus a. So this is the most equation frequently used in the problem. And also from this equation we can also conclude another equation. So that is the equation is the relationship between degree of saturation and water ratio, water content and specific gravity. So wg is equal to s into e. While replacing while here g, so g multiplying with the 1 and multiplying with the water content, we can get G plus GW. So in the replacement of GW, so we can replace this by SCA. So automatically there's another equation we got. Okay. After this, we can bring another equation also. So that is degree of saturation for saturated cells. The degree of saturation is 1. So why? Because of it is the degree of saturation is, it is the ratio of weight of water by volume of water by volume of voids. It is the ratio of volume of water by volume of voids. For degree of saturation, so the total voids is replaced by water only. So therefore weight of volume of water by volume of water. So automatically we get 1. So in this above equation, if we replace this s by 1, so automatically the above equation may turn into this equation. Okay, so this is also another equation. Next one, for dry condition of soils. For dry condition of soils, we have degree of saturation is equal to 0. Why? Because again I will explain. So degree of saturation is equal to the volume of water by volume of voids. But in the dry condition soil, so the dry means there is no water content, so the volume of water is 0. Therefore 0 by something, so 0. Therefore degree of saturation is 0. So therefore in the previous equation, when the degree of saturation is replaced with 0, so automatically the equation is 0. So therefore final equation is G into gamma W by 1 plus C. This is also one more important equation. So next one, submerged inverter. So many equations are available. All these equations are explained in this material clearly. So you should go once for all relations between the points, between the parameters. Okay. Next step is again. I mean, again, if you do not understand the specific gravities, I will explain you clearly by these pictures. So these pictures, this is the specific gravity of solids. The specific gravity of solids we can get by, it is the ratio of the, it is the ratio of the, it is the ratio of the unit weight of solids to the unit weight of water. Specific gravity of solids we can get by unit weight of solids to the unit weight of water. Okay. Now for bulk unit weight, so bulk mass specific gravity or apparent specific gravity we can get by, it is the ratio of bulk unit weight of soil to the unit weight of water. In specific gravity of solids, only we are taking only solids only. So it is the ratio gamma s is equal to weight of solids by volume of solids only. In bulk mass specific gravity, it is a ratio of bulk unit weight is a unit weight is gamma is equal to weight by volume. The weight is the total weight of the soil. That means it is the ratio of soil and water. So weight of soil by its volume. So it's volume. Okay, to the it's to the unit weight of water. So for example, same specific gravity of water is unit weight of water to the unit weight of water. So automatically we get uh, one value. Okay. So for this example, okay. Next one. So next topic is density. So determination of density or mass density. So next one, measurement of mass density. Density, the definition or mass density or density is the ratio of mass per unit volume of the soil. The ratio of the mass per unit volume of the soil. So density is equal to mass by volume. So gamma D is equal to gamma by 1 plus W. So gamma D, generally why we are using gamma D? So generally we are using the gamma D in the field, so mostly used in gamma D because it gives the true value of the soil nature. So that's why gamma D is the most important parameter in order to find the density of any natural soil deposit or compacted soil. In this density uh, we can find by mass by volume. So mass we can easily calculated by its measuring its weight by weighing machine. So mass we can easily directly measured by its weighing machine, or which may calculated its weight. Okay, but the volume of soil we cannot find easily. Why? Because soil has not a particular or definite shape. We cannot easily find out the exact volume of the soil. So for this, for for volume of soil we have so many methods. Out of this method, so we have in our syllabus we have core cutter method and sand replacement. The following methods are generally used for the determination of mass density. These methods are mainly useful for and indirectly it measures the volume of the soil. So in this method, core cutter method and sand replacement method both are available. So in core cutter method or sand replacement, so in both two methods generally we have to follow these steps. So easily in exam point of view, first of all, so for core cutter method or sand replacement method, so we have to first focus on the equipments. What are the type of equipments? And initially we have to find the calibration of cylinder or calibration of its container or a calibration of its soil volume. And the next one, after calibrating of its volume of cylinder or container, we can go to the measurement of soil density. After the soil density, we can go to dry density and void ratio. All parameters are sequentially follows. So for in this method, first we have to find out the what are the equipments in the core cutter method or sand replacement method. So for this, so in order to find the dry density of the any soil, we have two methods: core cutter method and sand replacement method. So we have for this method we have mainly three equipments. So the bottom portion is known as dolly, core cutter. Above this core cutter we have dolly, and above this core cut dolly we have some compact for a compactive energy or dynamic energy we have rammer. So the core cutter having sharp edge at the bottom of the soil. The dolly we can easily replace and mount on the top of the this core cutter. So this is the core cutter, this is the dolly, and this is the rammer. So equipment is completed. Now we have to find the this volume, the volume of the container. The volume of the container we can easily find out by its pi by 4 d square into height. So diameter of this core cutter and its height. So by after we calculate these two, we can get the volume of this container, volume of this core cutter. So in this method, generally we do this type of this method is only applicable for only sands or maybe purely sands or maybe normal soils. It should this method is not applicable for gravel sands and also for very hard soils. So this method is suitable for soft soils or maybe simply normal sands only. Okay, this method is not suitable for gravels or hard stratum type of soils. So in this method, first we have to apply the grease inside the core cutter. So after core cutter, so the initially the subsurface of the soil is removed at a depth, because of if it is natural condition you have to remove the top surface from the any impurities, or maybe if you have a compacted soil you can directly place this core cutter on the top of the soil. So after place of this core cutter you have to provide the dolly on this spot. So because of this rammer is placing on this core cutter, it may happen. So in order to avoid the damage of this core cutter, we are providing the dolly on this top. So in this top we provide the rammer by compactive energy. By giving compactive energy, it is slowly driven into the soil. So slowly driven into the soil. After finally we get the reach up to this point, only the dolly is penetrating. Just the total height of this dolly is 25 mm. So out of this 25, whenever the 15 mm is remaining, so now the stop procedure is stop, and remove the surface surrounding soil from this pit, and replace this soil from this place to next to into the lab. So where any the excess soil present in the dolly and the core cutter is core cutter is striken by cutting edge or any other tool to excess soil removed on the top of the surface. So initially we have to find the weight of this core cutter, and after this is known as m1, and after the with the soil we can find out this mass as m2. So we can get by the density is equal to mass by volume. So the density, the mass of the soil we can get by initial final weight by initial weight. So m2 minus m1 we can get the mass. So by this way we can get the density of the soil. So mass by volume. For volume we already told that the volume of this core cutter is pi by 4 d square into height. The diameter of this core cutter we can measure by scale or any device. The height also. So by this way we can find the bulk density. After bulk density we can find the dry density. So already I told you that in this after measurement of soil density we can find the dry density. After dry density we can find the void ratio. So the dry density we can find by it. Already in the previous class we discussed this relation gamma by 1 plus w. So gamma means it's the bulk density by 1 plus w, where w means water content. The water content can be calculated by its weight of water by weight of salt. Along in this sample, take in between middle of the soil sample, take some amount of soil and initial weight, and it place it into the oven, and we can get the final weight. So initial weight by final weight get the water content. So it is the bottom place, and the water content definition is weight of water by weight of solid. So water content we can get by W2 minus W1 like this manner, and weight of solids is the final weight. So with this way we can get the water content. So this